Assalamu alaikum. I'll do problem 10.36, which is basically we need to find the shortest path from Seattle to London. And these are the different nodes that we have to go through. So again, let's start. We start from Seattle here. And the closest connected unsolved node, which is we need to now look at A, B, and C. The minimum is 4.2, so that's C. Total distance is 4.2, and this is again the minimum distance, so the nearest node would be C, and the connection we are making is from Seattle to C. So now we can label node C. Let's first start labeling node Seattle. So nothing before, and total distance is 0. So now for C, I have we're coming from Seattle, and the total distance is 4.2. Okay, so this is the label. Okay, let me just now distance here. Okay, right. So now we have two labeled nodes. So to continue, again, the second iteration we can start from, we can start from Seattle. We can start from Seattle, or we can start from C. Now for Seattle, we need to consider between A and B. And the shortest distance is 4.6 to A. So that's now here from Seattle to A, and the distance is 4.6. And for C now, we need to check. C can go to either E or F. Okay, the minimum distance is to F, that's 3.4. So now I'm going to choose this one here, C to F. Okay, so now the distance is 4.2 plus 3.4, so that's 7.6. Total distance involved is 7.6. I got this from basically this 4.2 here plus the 3.4 to F, so that's the total distance is 7.6. Now the minimum distance again is 4.6, and that's to A. So the connection I'm making is from Seattle to A. So now let's go ahead and label node A. So node A now we can reach it from Seattle, and the total distance is 4.6. Okay, so now we update for iteration, update the first column. Here we can, from Seattle, we can reach it, we can also consider C, and we can consider node A. Now for Seattle, the only node left for Seattle is basically unlabeled node, which is B. So I'll put B here. And the distance involved is 4.7. Now for C, let's see here, for C we can consider again E or F. The minimum distance would be to F. So again from C to F, and the total distance involved is 7.6. Now for A, we need to go back here. For A now we can either go to D or E, and the minimum distance is to E, which is 3.4. So let's put it here first, A to E. Okay. And now we need to write the total distance involved. So that's 4.6 plus 3.4, which is equal to 8.0. Okay. So now we have these three possibilities. Alternative, we look for the minimum distance. Minimum distance is 4.7. So that's 4.7. That's node B. So the new connection made is Seattle to B. So now node B is also labeled. It is labeled. I can reach it. Let me just case here. We can reach it from Seattle, and the total distance involved is 4.7. Okay. So now let's take a look here. Seattle is connected to A, B, and C, and all these three are what now they are labeled. So Seattle will no longer be considered. So let me just go back here to my table. So in iteration 4, we're not going to be considering Seattle anymore. So let's this here. So we'll start with A. And we have B and we have C. Seattle is no longer considered. So now we go back to A. A, we can reach E. So for A, we can reach E, and the total distance involved is 8. Now let's consider B. See where can we reach from B. From B, we can go to D. We can go to E and we can go to F. However, the shortest distance is to E. So we are going to consider BE now. So this is BE. And the total distance involved will be 4.7 plus 3.2, that's 7.9. So that's 7.9 here. Now for C, again, it will be to F, and that will be 7.6, the total distance involved. So again, we look for the minimum distance. Minimum distance is 7.6, and that's the connection to F coming from C. So now the connection will be CF. So now let's take a look here. We go to F and we put a new label for F. So now the label for F, we're reaching it from C, and total distance involved is 7.6. Okay. So now F is labeled. So now we need to consider it in iteration 5. So now for iteration 5, we still can go from A to E, and we can, this is distance of 8. So let me just put this here, draw this line here. We can go from B to E, and that's 7.9. And we can go now, if you noticed, we can go from C. Now still C is considered because C can reach E. So we will update it now, C. Now C to E. Okay. C to E, and the total distance involved will become 7.7. And we have F now, which is basically for F, we can reach directly to London, and the distance involved will be 7.6 plus 3.8 here. So let me put it here, F to London, and the total distance involved will be 11.4. That's 7.6 plus 3.8. Okay. Now again, we look for the minimum distance. Minimum distance is 7.7, and that's the connection to E. That's the connection from C to E. So now E is labeled. So let me go back up here and let's put a label to E. E, the new label to E is going from C to E. So it's coming from C. And the total distance involved is 7.7. So that's here. This is the label for E. Okay. So now you notice that C is connected to only labeled nodes, so C is no longer considered in the first column in iteration 6. Okay, so now I have A. Let's go back to A. A is now connected to D, to unlabeled node D. So now let me just change the color. So, okay, so now for A, we have, this is iteration 6. This is iteration 6. It will go to B. And also for B, let's do this here. For B, we can either reach D or E or F. E and F are both labeled, so I can only reach E. So from B to D. And again, C is no longer considered. So now we need to put F and E. So F and E here. Okay, for F and E, let's see where can we go from F and E. F we can reach London and E can reach London as well. So this is London, this is London, this is London. Okay, and now let's see the total distance involved for A to D. That would be 4.6 plus 3.5. So let me go here for A, that's 4.6 plus 3.5. So updated here. So that's 8.1. And BD in similar, we can say it is 8.3. Now F to London, that's 11.4. And we have 11.3 for E to London. Okay, so this is now. Now the minimum would be again 8.1. And that's the connection from A to D. So this is D here, and this is the connection A to D. So now D is labeled. So let's go up here and label D. So now D is, we have a label for D, and this is the label. And it's approaching from A, and the total distance is 8.1. Okay, so now this is 8.1. Let's go now. So now notice here A is connected to labeled nodes. So A is no longer considered. B is now also connected to labeled nodes. And C is also connected to labeled nodes. This we know from the previous iteration. So now for iteration 7, we can only consider D and E and F. Okay, they all can reach London. So this is London, London. Now we need to calculate the total distance involved for D. Let's go back here. For D, we have the distance, it's 8.1 plus 3.4. For E, it is 7.7 plus 3.6. And for F, it is 7.6 plus 3.8. So let me update the table here. That's D to London, 8.1 plus 3.4. Again, that's 11.5. And E to London, that's 11.3. And for F, we have F is 11.4. So again, the minimum distance would be 11.3, and the connection will be made through E to London. Okay, and the connection will be through E, so that's E to London. Okay, so now I can label, so that's E to London. So this is now reaching from E, and the total distance involved is 7.7 plus 3.6, that's 11.5. 11.3. Okay, so now we labeled London, and therefore this is the shortest path. That's is going to be from Seattle. Okay, Seattle to C, and C to E, and then from E to London. Total distance equals to total flight time is, so here we have total flight time is equal to 11.3.